Hi, so in this video we're going to be looking at follow-up to the last video on the gamma function's relation to factorials. We're going to be looking at how we find the factorial function that, or not a function, a number that is not an integer. So we're going to look at factorial of a half. So let's recall that the gamma function is defined like this, and the gamma of some variable z is going to be that number minus 1 factorial. So let us use this and find what 1/2 factorial is. So we're going to plug obviously 3/2 into the gamma function, and that's going to give us this integral. So t to the half e minus t dt, and we'll just proceed as normal with our integration by parts. We're going to get this expression down there, 1/2 root t. Our dv is going to be e to the minus t as normal, and we're going to get minus e to the minus t. So we'll then have minus t to the half e to the minus t between 0 and infinity. We're going to get this integral, and that then is going to be e to the minus t over 2 root t dt. Now, we can make a good substitution here. We note that we've got a square relationship here. Root t squared is going to be t. So we're going to say let u equal root t. So our du is going to be 1/2 root 2 dt. And that works really well because we've got that there. So that means then that t is going to equal u squared. So we get the integral, obviously this goes to 0 as well, I forgot to mention, as always. We're going to end up with the integral of e to the minus u squared du. Now, I'm going to do a separate video on this, but there's an integral called the Gaussian integral. Named after Carl Friedrich Gauss, normal distribution, very famous mathematician, who has a result that this integral is the square root of pi. So that is the area under this curve, which looks very normal, similar to the normal distribution, and this is a non-normalized version. So the normal distribution is an example of a Gaussian distribution, which is why in the Gaussian distribution you have a 1/√2 pi term to kind of normalize it so that the probability or the area under this will always equal 1. So that aside, if the integral between infinity and minus infinity is root pi, then that means that this integral is just going to be square root of pi divided by 2. So that means that 1/2 factorial is root pi over 2. So a bit of an obscure result, but that's how we compute it.